Solid is a reactive JavaScript framework for building performant web apps. In this video, we will understand what fine-grained reactivity is and how does it work in Solid. Let's start by creating a relationship. As the name says, double count multiplies the value of count by 2, and if we log into the console, we can confirm the relation. Though if further down we increment the value of count, the relationship breaks as double count is unable to react to the value of count. Solid allows us to preserve this relationship via a signal. With the createSignal method, we receive back a getter, also called an accessor, and a setter, which we can use to update the value of the signal. Like this, we can wrap double count in its own getter and make it reactive to count. Because each getter is a function, it will retrieve the actual current value of count every time it is called. If we replace count plus 1 with our signal getter, it should work. And because we want to log into the terminal every time double count changes, we can wrap our console log into a side effect callback with the createEffect method. And now, even if we wrap our setCount into a set interval, the program will continue to log the value on every update. And these heuristics scale well as your code complexity increases. To see that, let's add a multiplier signal and convert double counts into a derived product. Now we will increment the multiplier in a 3-second interval. And you see each signal gets updated in its own interval with effect running every time. To recap, we have seen how to use signals, derive signals, effects, and how to update our signals. Let's investigate how this reactivity model works in Solid. Signals are synchronous in nature, so Solid's engine can base its system in a signal stack. Stack is a data structure where the last item in is also the first item out. And therefore, we can implement a method that will return the top of the stack so the engine knows what's next to be executed. With this system in place, we can implement our effect system. The effect will push itself to the top of the stack, execute whatever its callback is, and finally remove itself from the stack. For the signals to work within the observer pattern, there are a few adjustments needed. At its core, a signal has two methods, one to get the value and another one to set the value. What we then need is a list of subscribers to the signal, everyone which is affected by a change in it. When a getter is called, it will add the current observer to its subscribers before returning the value. And when a setter is called, it will run through the list of subscribers, calling them right after redefining this value, thus closing the loop of our reactive system. Now, instead of outputting to the console, let's create some HTML. With some vanilla JavaScript, this is how we would do. And now in our createEffect callback, we will replace the console log with some text content. Sure enough, it works. Still, we could use some interactivity. Let's remove these set intervals and create some buttons. Thankfully, SolidJS allows us to write HTML-like syntax into our code. That's JSX. With the curly bracket syntax, we can create an on-click handler that will update count when triggered. Then we can do absolutely the same with the multiplier. Finally, we add the JSX to our append call, and voila, it works. But Solid still allows us to write more declarative code instead of directly appending things to the DOM. We will now wrap this code into a single component. In Solid, components are just a way of co-locating the code for better readability. Our signals can be either inside of it or not, as they weren't before. And to make things more convenient, we now replace the document append call with the render function from Solid Web. It will receive our app component as a first parameter, and as the second, the DOM element in which we want to append our app. We can also then get rid of this createEffect, as SolidJS compiler is going to be able to pick up the signals interpolated straight into our JSX and create the effects accordingly. So just like that, we have our interactivity with nice declarative code. Finally, let's create a wrapper component and instantiate our app multiple times. We can use the JSX syntax to treat them as if they were another HTML element. This is nice, so we can even pass an initial count to set a new first value to one of our instances. And just like that, one of our components starts with 100 instead of 1. And as we mentioned before, a signal can live outside of our component, and that will make it available in the outer scope. It will still work, but then each component will share the same signal instance. In this case, multiplier is global, so if I increment in the second instance, it will update for all of them. Whereas count is local state, so updating them only affects the instance where the update was triggered. It's important to note that in Solid, JSX creates real DOM elements. Components run once, and through fine-grained effects, Solid only updates what changes. And with that, we got a gist about what is reactivity in Solid and how it works. And I totally encourage you to look at the SolidJS docs. There's a special tutorial session that works like a crash course for beginner and advanced APIs. Additionally, there's a Discord community full of amazing people who are very enthusiastic about helping each other. So I look forward to see you there.